Hello everyone, today I will present about vector and scalar for Engineering Mathematics 1. My lecturer name is Puan Rovina Helene binti Hussein Mea.
Assalamualaikum. My name Nik Anam Hakimi bin Yusuf Fauzi. Matric number 09DJK21F1016.
My name is Nur Amira Akila binti Karuliza. My matric number 09DJK21F1013.
My name is Nurfa Jaira binti Azhar. My matrix number is 09DJK21F1088.
Definition: scalar are physical quantity that have only magnitude. The example of scalar are electric charge, density, mass, and other. Vector are the physical quantity that have both magnitude as well as direction. The example of vector are velocity, acceleration, force, and other.
Vector and scalar in engineering. Vectors are used in engineering mechanics to represent quantities that have both of magnitude and a direction. Many engineering quantities such as force, displacement, velocities, and acceleration will need to be represented as vectors for analysis. Vectors quantities contrast with scalar values such as mass, area, or speed, which have a magnitude but no direction. When dealing with vector in equations, engineers commonly denote something as a vector by putting an arrow over the variable. Variables without an arrow over top of them represent a scalar quantity or simply the magnitude of that vector quantity. Vector quantity. To represent a vector quantity, we will generally have two options. These two options are: number 1, magnitude and direction form, where the magnitude is given as a single quantity and the direction is given via an angle or combination of angles. Number 2, component form, where the magnitude and direction are given through component magnitude in each coordinate direction. To see the difference in vector quantity, they have an arrow to show their direction, while scalar quantity didn't have an arrow to show their direction. In contrast, with scalar quantities, we cannot add, subtract, multiply, or divide them by simply adding, subtracting, multiplying, or dividing the magnitudes. The directions will also play a critical role in solving equations that contain vector quantities.
Scalar quantities are those with which only a magnitude is associated. Example of scalar quantities are time, volume, density, speed, energy, and mass. Example of vector quantities are displacement, velocity, acceleration, force, moment, and momentum. Speed is a scalar. Example, mass, the property of an object of about the strength of its gravitational attraction toward other bodies. For example, we can describe the mass of an elephant as 500 kg. Speed. Average speed can be defined as the total distance traveled divided by the total travel time. When you are driving on the interstate, you are likely going at a speed of around 65 miles per hour.
Next, vector and scalar application in engineering. In engineering, vector and scalar can help facilitate construction that require coordinate readings such as aircraft and submarine. A navigation is an electronic device used to show direct to something we want to go. In navigation, vectors have a great influence on the location of an observed location from a moving place such as a vehicle and the like. For example, vectors are used for aircraft navigation system. All aircraft are equipped with a navigation system so that the aircraft does not get lost while flying. With the vector system calibrated by the aircraft navigation computer, the pilot can monitor the aircraft landing even at night.
Vectors cross product of two vectors. Cross product of two vectors is the method of multiplication of two vectors. The cross product of two vectors is the third vector that is perpendicular to the two original vectors. Its magnitude is given by the area of the parallelogram between them, and its direction can be determined by the right-hand thumb rule.
Next, cross product definition. If A and B are two independent vectors, then the result of the cross product of these two vectors, A times B, is perpendicular to both the vector and normal to the plane that contains both of the vectors. It is represented by A times B equal AB sin theta.
Okay, this is a vector cross product film.
Cross product matrix Nash formula. The cross product of two vectors is also represented using the cross product formula as this is the formula.
For example question is
Okay, example 1. First read the question. Use the formula A cross B. Okay. For question A equal to 2i plus 3j and B equal to negative 2i plus 9j. Okay, A cross B. So we write the formula. Okay. For A, I is 2 and J is 3 and K is 0. For B, I is negative 2, J is 9 and K also 0. Okay. We write the formula. Okay, first we must to close the row of I. So we have 3, 0 and 9, 0. So 3 times 0 is 0 and 9 times 0 is 0. Okay, next we close the row of J and we have 2 times 0 is 0 and negative 2 times 0 is 0 and negative is positive. And K, we close the row of K and we have 2 times 9 is 18 and negative 2 times 3 is 6 and negative is positive. Okay, so we have 0i minus 0j plus 34k and the answer is 34k. Okay, for question B, A cross B equal to I positive, J negative and K positive. Okay, for I, 4, J negative 2 and K 0, and B, I is 5, j is -7 and k is 0. So use the formula. So close the row of I. So we have -2 times 0 and -7 times 0, and we get 0 plus 0, because negative and negative is positive. And next, close the row of j, and we have a 4 times 0 is 0, and 5 times 0 is 0, and we get 0 minus 0. And next, we close the row of k, and we have 4 times -7, we get -28, and 5 times -2, and we get 10. So -28 plus 10, and we calculate, and we get the answer is -18k.
Question 2. Use determinants to find the vector product P times Q in each of the following cases. A. P equals I plus 4J plus 9K. Q equals 2I minus K. A. P times Q. The result is -4 minus 0 I minus -1 minus 18 J plus 0 minus 8 K. The answer is -4I plus 19 J negative 8 K. B. P equals 3I plus J plus K. G equals I negative minus 2J minus 3K. B. P times Q. The result is -K plus 2 I minus -9 minus 1 J plus -6 minus 1 K. The answer is -I plus 10J minus 7K.
For the vector P equal I plus J plus K, Q equal -I minus J minus K, show that in this special case, P times Q equal Q times P. A. P times Q equal I J K. The result is -1 plus 1 I plus -1 plus 1 J plus -1 plus 1 K. The result is 0. For B, Q times P equal I J K. The result is -1 plus 1 I minus -1 plus 1 J plus -1 plus 1 K. The answer is 0. Both cross product equals 0, and so in this special case, P times Q equals Q times P. In conclusion, student can calculate vector and scalar. Vector and scalar are equal units of units and time. Vector can be defined in two-dimensional or three-dimensional space. Vector graphics are sometimes used in computer because they can be split to a large sign without losing any image quality.